Hello everyone. Today we are going to derive an expression of screen effectiveness. Now, screen effectiveness is the parameter which can be used to determine the performance of the screen or to understand the performance of the screen. Now, what is its definition? Its definition is ability of the screen to separate the oversize and undersize perfectly is known as screen effectiveness. Now, how to determine this screen effectiveness? Now, to determine screen effectiveness, the formula for screen effectiveness is used and the values of the variables are substituted and the effectiveness either based on oversize or based on undersize or overall effectiveness is determined. Now in this session, we will be deriving an expression for determination of screen effectiveness, rather calculation of the screen effectiveness. So let us begin the derivation of screen effectiveness. So as discussed, screen effectiveness is the ability of screen to separate oversize and undersize material perfectly. Now we may determine the effectiveness based on oversize, effectiveness based on undersize, or effectiveness based on, the combined effectiveness or say overall effectiveness. So to begin with the derivation, just consider the schematic sketch of the screen. Say this is the screen and to this screen the feed F is fed. So due to the screening, some material is retained over the screen. So that is oversize material, and say the overflow which contains oversize material is denoted by D. Underflow is determined by B. So F stands for feed, D stands for overflow, and B stands for underflow. Now, our objective is to derive the mathematical expression for determining the effectiveness of the screen. So, before we proceed further with the derivation, let us define some variables which we will be using during the derivation. Let xd represent mass fraction of oversized material in overflow. Let XB represent mass fraction of oversized material in underflow. Let XF is equal to mass fraction of oversized material in feet. So you must have realized that I am considering one particular fraction and accordingly the variables are defined. So mainly I am considering oversized material. So during screening, when the feed will be fed, that feed will consist of some amount of the oversized material. So ideally, all oversized material should be in an overflow. So ideally, the value of XD should be 1. But it will not be, because majority of the screen or the screen used in a real life are works as a real, behaves as a real screen, not the ideal screen. So there is always overlap of oversized and undersize. Some undersized material is present in overflow, some oversized material is present in underflow. So after defining these variables, what we will do is we will write the component balance and the material balance also. So by taking material balance, we can write F, that is feed, which gets into divided into two fractions. Feed is equal to overflow plus underflow. Say this is equation number 1. Now since we have specified some variables, we will try to write down the component balance or the balance based on oversized material. So by writing material balance for oversized material, we get, now please remember, for writing the material balance based on oversized material, it will be, say, F is the feed which is fed to the screen, and it consists of XF, that is mass fraction. So mass fraction of the oversized material present in overflow multiplied by feed will give, mass fraction of the oversized material present in a feed is XF multiplied by F. So it will represent the oversized material present in the feed. Now it will get divided into overflow and underflow, and therefore dxd plus pxb. So if I have to read it in word, then it can be read as oversized material present in feed is equal to oversized material present in overflow plus oversized material present in underflow. But please remember, the feed consists of oversized material also as well as undersized material also. So we can also write the material balance for undersized material. So for undersized material, we can write the balance as F into 1 minus XF. So if XF is the weight fraction or mass fraction of oversized material in a feed, so 1 minus XF means mass fraction of undersized material in feed is equal to D. XD is the mass fraction of oversized material in overflow. So 1 minus XD is the mass fraction of undersized material in overflow, plus B is total underflow. If XB is the mass fraction of oversized material in underflow, so 1 minus XB is the mass fraction of undersized material in underflow. Now let us say that this is equation number 3. Now next is to calculate the effectiveness or based on oversize, based on undersize and overall effectiveness. Instead of calculation, I will say that to write the expression. So effectiveness based on oversize is equal to amount of oversized material in overflow divided by amount of oversized material in a feed. Say this is equation number 4. Now this effectiveness based on oversize is denoted as EA is equal to amount of oversized material in overflow. So total overflow is XD multiplied by mass fraction of oversized material in overflow, that is XD. So DXD upon total feed F multiplied by mass fraction of oversized material in a feed XF. Equation number 5. Now since D and F are not easy to determine, we will try to determine the value of D by F in terms of XD, XF and XB. For that we will be using equation 1 and 2, that is overall mass balance and component balance. So let us do that. So once again, for the sake of continuity, I am writing the equation F is equal to D plus B, and the balance or the overflow is FXF is equal to DXD plus BXB. Now my objective is I want to find out the value of D by F. So what I will do, instead of this B, I will substitute the terms in terms of F and D. Therefore, from equation 1, this I'm just rewriting this number again. From equation 1, we can write B is equal to F minus D. Say this is equation number 6. So substitute equation 6 in 2. So FXF is equal to D into XD plus, instead of B, I will be substituting F minus D into XD. So open the bracket and simplify. So FXF is equal to DXD plus F into XB. I am opening the bracket, and D into XB. So collect the similar term. So just transfer this FXF to LHS. So FXF minus FXB is equal to DXD minus DXB. So what I can do is I can take F common from LHS and D common from RHS. So F inside the bracket XF minus XB, D inside the bracket XD minus XB. F inside the bracket XF minus XB, D inside the bracket XD minus XB. So in this way, I can take d by f on one side and remaining on another side. So d by, if you take this f to this side, so d by f will be equal to xf minus xb divided by xd minus xp. Therefore, I can write d upon f is equal to xf minus xb divided by xd minus xb. This is equation number 7. Therefore, substitute equation 7 in equation 5. So equation 5 was EA is equal to d by f xd divided by xf. Therefore, xd d by f. Now d by f is xf minus xb divided by xd minus xb multiplied by xd divided by xf. This is equation number 8. So if somebody asks you to calculate the effectiveness based on oversize, and if the value of xf, xb and xd are known, you can just write over here and you can find out effectiveness. If you have to find out if efficiency based on oversize, then whatever the value of effectiveness is obtained, if you multiply it by 100, then you will get the efficiency based on oversize. Okay, so d by f, we can write it as xf minus xb upon xd minus xb. So just above previous equation is just rearranged with d by f on one side and remaining on another side. And the equation 7 is substituted in equation 5, that is effectiveness based on oversize. So dxd divided by fxf, and if you substitute, then you will get the effectiveness based on oversize, right? Now the simple way to understand the d by f is what you have to do is just write the mass fraction of the term in a denominator, in the numerator xf, mass fraction of the term in a numerator, in a denominator xd, and subtract the term, mass fraction of the term which is not present in this. Now the term which is not present here is xb, so subtract from that. So see, minus xb minus xb. So in this way we can calculate the effectiveness based on oversize. Now we will calculate effectiveness based on undersize. So effectiveness based on undersize is equal to amount of undersize present in underflow divided by amount of undersize present in feed. So this effectiveness based on undersize, say this is equation number 9. This is denoted as EB, effectiveness based on undersize, and that is equal to, or it is equal to, undersize material is B. Now if xb is the amount of oversize material present in underflow, so 1 minus xb will be amount of undersize material present in underflow. Similarly, feed is f. If xf is the amount of oversize material present in feed, then 1 minus xf is the amount of undersized material present in feed. So EB, if you wish, you may write it here. EB is equal to B into 1 minus XB upon F into 1 minus XF. This is equation number 10. Now we just have to replace this B and F similar to D by F. So we have to again consider equation number 1 and 2. Therefore, for replacing B by F, consider equation 1 and 2 again. Therefore, from 1 we can write, or by using 1 we can write. Now please remember, we shall eliminate D and we shall write it in terms of B and F, and therefore F is equal to D plus B. Therefore D is equal to F minus B. D is equal to F minus B. Now substitute this D is equal to F minus B into equation 2, and therefore F into, see now XF is equal to, in place of D I will be writing F minus B XD plus BXB. So just open the bracket. So for replacing B by F, consider equation 1 and 2 again. So D is written as F minus B. So FXF is equal to, in place of D, F by F minus B XD plus B into XB. Now we have to open the bracket and simplify this equation. So FXF is equal to F XD minus BXD plus BXB. So again rearrange the term, collect the term of F on one side and the term of B on another side. So what we will do is, we will take all the terms of B on LHS and the term of F on RHS, and we'll just take B and F common from the expression. So let us take the term of B on LHS. So minus BXD, if you take to LHS, it will be BXD, and plus BXB, if you take to LHS, it will be minus BXB, is equal to FXD, and if you shift FXF to RHS, then it will be minus FXF. So just take B common. So B outside, XD minus XB is equal to F into XD minus XF, right? So B by F is equal to XD minus XF divided by XD minus XB. This is equation number 11. So if you substitute equation 11 into equation 10, then we will be able to get the expression for effectiveness based on undersized. Again, if you don't remember the expression for B by F, now here we are deriving step by step, so you will be able to obtain this. But if somebody asks you what is the expression for B by F in terms of XD, XF, and XB. So what you can do is simple thing. Take the write the mass fraction of the material in the denominator in a numerator. So F is in a denominator. So XF. Now B is in a numerator. So XF divided by XB, and the term which is not present over here is D. So subtract the weight mass fraction of that term. So XF minus XD divided by XB minus XD. Now you will say the order is changed. No problem. Even if you write XF minus XD and XB minus XD, the answer will be same because negative sign will get cancelled. But let us continue with this and substitute equation 11 in equation 10, and therefore we get EB is equal to, in place of B by F, now we are substituting XD minus XF divided by XD minus XB multiplied by 1 minus XB divided by 1 minus XF. This is equation number 12. And now last few steps. Overall effectiveness is equal to effectiveness based on oversize multiplied by effectiveness based on undersize. Effectiveness based on or overall effectiveness is equal to effectiveness based on oversize multiplied by effectiveness based on undersize. Now overall effectiveness is denoted by E. Effectiveness based on oversize is EA. Effectiveness based on undersize is denoted by EB. So substitute value of EA from equation 10 and value, not value, say terms of EB from equation 12. Therefore, E is equal to I think it's not equation 10, it's equation 8. So EA is equal to XF minus XD multiplied by XD divided by XD minus XB multiplied by XF. Now this is EA. Now we have to substitute the value of EB. So EB is XD minus XB, XF divided by XD minus XB multiplied by 1 minus XB upon 1 minus XF. Now you can see that this XD minus XD minus XB, there are two terms, and therefore I can simplify it as EA is equal to XF minus XD multiplied by XD multiplied by XD minus XF multiplied by 1 minus XB divided by xd minus xb. Now xd minus xb, xd minus xb, so xd minus xb square multiplied by xf multiplied by 1 minus xf. So in this way, by using this expression, the effectiveness of this is overall effectiveness. This is overall effectiveness. E can be calculated as overall effectiveness. E is equal to effectiveness based on oversize multiplied by effectiveness based on undersize. So this represent EA, this represent EB. So the product of effectiveness based on oversize multiplied by effectiveness based on undersize is equal to E, that is overall effectiveness. Now, what does it mean by overall effectiveness? What is the significance? Say, for example, if the overall effectiveness is 0.8, that means efficiency will be 80%. So what is the meaning of this? 80% oversized material will be present in overflow, 80% undersized material will be present in underflow. Say if effectiveness is 0.9, that means efficiency is 100%. So what is the meaning of this? If effectiveness is 0.9, that means efficiency will be 90%. So what is the meaning of this? 90% oversized material will be present in overflow, or 90% undersized material will be present in underflow. So once the effectiveness is known, then we can calculate efficiency is equal to effectiveness multiplied by 100. So maximum effectiveness is 1, so maximum efficiency will be 100. So you may write it as a percentage efficiency. So it's quite lengthy, but it is very, very simple. So I hope if you watch this video, you will understand each and every step in a derivation of expression for calculating the effectiveness of the screen. We may calculate the effectiveness based on oversize, effectiveness based on undersize, and overall effectiveness also. Thank you very much for watching the video. Thank you once again.